All right, thank you so much, guys, for coming today. Thank you. So today we're going to do lecture 18, brain structure and function. We're going to cover all the parts of the brain, and we're going to talk about their function. It so turns out that in the modules, the problem you had was matching the structure to its function. So we're going to try to go through that in a little bit detail today. So here's the brain. Okay, it's in the cranial cavity, right? In the skull, it controls a lot of body functions. All the homeostasis that occurs in the body in terms of maintaining everything in a stable internal environment is controlled by the brain. That's what we called, when we talked about the homeostatic mechanisms, the control center, because it's got the set points or the values for each of the activities in the body. So it's the major control center, right? Okay, so it's got 4 major parts, and then we'll try to break down those 4 major parts into smaller, structures and talk about their functions. Okay, pretty much I liken the brain to an ice cream cone. You can pick your favorite flavor. The brainstem holds it, and the cerebrum is the ice cream. So you have something like that. Okay, the brainstem has got 3 parts. Okay, then the cerebrum is kind of like that. Okay, so that's your ice cream, right? And this is your cone, the brainstem. Okay, and then behind it is the cerebellum. Okay, so you got the cerebrum here. Okay, and we'll talk about that last. Okay, then you've got the the brainstem is made up of the medulla oblongata, which is the structure that is continuous with the spinal cord. So medulla oblongata. Okay, and then the middle part of it, it's a much bigger bulge than that. It's called the pons. All right. Pons is a Latin word meaning bridge. It pretty much is a bridge of information from the lower parts, like the spinal cord and the medulla, to the upper parts, which is the cerebrum and the diencephalon. Okay, so this will be the midbrain. The last part of the brainstem is the midbrain. Okay, so that's your cone right there. The ice cream is made up of, this cerebellum here, like Lady Antebellum. Okay, I couldn't resist that. Okay, so the brainstem has got those 3 parts, and then the diencephalon is kind of like in the middle here. It's made up of the thalamus and the hypothalamus. Okay, the hypo means under the thalamus. Okay, so the diencephalon, the major parts is the thalamus, and you will later see that almost all the senses, in fact all the senses go through the thalamus on their way to the brain except the sense of smell, okay? And then the hypothalamus. So it's good to kind of understand the structure of it right now, because then we're going to split all these into the different functions, right? Okay? And there are other nuclei as well under the thalamus, or hypothalamus, like the pineal body and the pituitary, which is right in there in the cellular tissue. Okay, and so the hypothalamus controls those parts. All right, so that's pretty much it. And then we'll talk about each part and talk about what each part does. All right, so there's the brainstem. You got the medulla, the pons, and the midbrain. All right, okay, and then the diencephalon is kind of like in the middle here. All right, made up of mainly of the thalamus and the hypothalamus, and then the cerebrum has got two hemispheres, and then that's also split into lobes, which we'll talk about, 5 of them. Okay, and most of those lobes are named after the bone under which it occurs, right? Like the parietal disc and the under the parietal bone. So you kind of know about them already, okay, because you did the skeletal system, all right? And then of course the cerebellum at the back there. So those 4 main parts, and they're divided into smaller parts that we will talk about each of their functions. All right. So this is an actual dissection through an actual brain. You can see the cerebellum has got this sort of structure that is called arbovitae, and we'll kind of talk about it. Arboretum means trees, right? You can see it looks like a tree with the branches and everything. So that's where the name comes from. The white matter in there is structured like a tree. All right. And there is the pons, the big bulge here, which is a bridge between the medulla, the lower structures, the spine, and the upper parts of the brain. Okay? The midbrain, the diencephalon, and the cerebrum. All right? So you can see the diencephalon, then the brainstem, those three parts. All right? The cerebellum literally means small brain. It's got two hemispheres as well, and it's got a connector between the two hemispheres called the vermis, and we'll talk about that. And the main part, the cerebrum, is also got two cerebral hemispheres and a fission in the middle called the longitudinal fission. All right? So, here goes. So we'll talk about the brainstem first. We'll talk about the three parts though, and talk about each of those, the functions of each part of the brainstem. Okay, so we've got the medulla, which is the lowest part of the brain. It tapers into the spinal cord. And then, of course, the pons, which we said is a bridge. That's what it literally means. It's a bridge of information from the lower parts to the upper parts of the central nervous system. And then, of course, the midbrain is just before the diencephalon. All right. So, like I said, the brainstem connects the spinal cord to the cerebellum and the cerebrum. Okay, the remainder of the brain. Actually, the brainstem is the most critical part of the brain. Okay, you can hurt big chunks of the cerebrum, but if you nick a small part of the brainstem, it could be fatal. Okay. Most of the time when I talk about the brain and the importance of the parts, I mention the congresswoman, Gabby Giffords, who was shot in the brain. She survived, but she had to relay. In fact, she was conscious when she went to the hospital. Okay? That's kind of freaky because the brain doesn't have pain receptors, the parts of the brain that were affected certain functions, but she didn't die. But if it had nicked part of the brainstem, because the brainstem controls things like respiration, heart rate, all those things, you could die. Okay? So, and the cerebrum is so big, and it's got so many neurons, they can reconnect other ways if a certain part is damaged, so you can relearn some things. All right? So that's what I'm talking about here. The brainstem is the most critical part, and it controls all the vital functions. All right, like breathing rate, cardiovascular system as well, and so it doesn't sustain big damages. Okay, so that's the thing. And the brainstem also holds 10 of the 12 cranial nerves. They arise from there. The nerves that start from the base of the brain, 10 of them, except the sense of smell, olfactory number 1, and sight, which is optic number 2. Those are the only 2 cranial nerves that do not originate from the brainstem. Okay? So, all the 12 of them, 10 of them originate from the brainstem. Alright? Alright, so this is it right there. Split up into bits. We got the thalamus on the top, alright, which is part of the diencephalon. And then, of course, the midbrain connects to the diencephalon, like the cerebral peduncle. It tracts that connects to the upper parts of the brain. And then, of course, the pons, the bridge, and then you can start to see some of the cranial nerves that originate from the brainstem. Right? I think towards the end of this lecture 19 or 20 or something, we'll be talking about the cranial nerves and their functions. All right? All right. There you go. So, we start start with each part of the brainstem. Remember, I said we're going to talk about the major parts, then each part will split it into its different components and talk about the function of each. So I can ask you in the exam about the specific functions of the medulla oblongata. Okay? So this is, of course, continuous with the spinal cord. Okay, it's the last part of the brain, so it will have ascending and descending tracts. Okay? That means ascending will be going to the brain sensory, descending will be going to the muscles and so forth to control all the activities, right? So sensory and motor, descending tracts. So it regulates, like I was saying, heart rate, blood pressure, breathing. There are several nuclei in there that contain, regulate breathing. But then there are some other non-vital functions like swallowing, sneezing, and things like that. Coughing, hiccuping. Balance is also kind of critical, and coordination. All right. So the main activities in the medulla is the breathing and the heart rate. Because it controls the blood vessels. The vasomotor center is located in the medulla oblongata. Vasomotor is got to do with control of the smooth muscle in the blood vessels. All right, which regulates the size of the blood vessels, and therefore the blood pressure. All right. So at the bottom there are pyramids. Because it kind of tapers like that. You see, it kind of goes like that, okay? And then from there, from here onwards, is the spinal cord. But there are tracts that come down, they come wide like that, and do that, and come wide like that, and do that, okay? So what is it? Right at the base of the medulla oblongata, they cross, and that's a term called decusate is to cross. And so that means the left part of the brain controls mostly the right part of the body, okay? And the left part of the right part of the brain controls the left part of the left body parts. Okay, so if your head on this side, you're going to affect function on your right arm, okay? For the most part, the left cerebral hemisphere is the dominant one because it's the one that controls the right. Even in left-handed individuals, the left tends to be the dominant hemisphere. Okay? That's because the tracts cross over. So this is coming from the right side of the brain, and it will go and control the left, and from the left to the right side, because of these pyramids, which control the muscle activity, voluntary muscle activity. Okay. All right. So there's your medulla right there, which is the last part of the brain that is continuous with the spinal cord. All right. Still on the brainstem now, the pons. The pons is the mid piece of the brainstem, and we said it's like a bridge. It connects the upper parts of the brain to the lower parts of the central nervous system. So it also has these ascending and descending tracts that pass through there, the pons, and then it also connects to the cerebrum and the cerebellum, right? Because it's right there. So there are little nuclei. Remember we said a group of neurons, cell bodies in the central nervous system is called a nucleus, right? So that's all that means. It's a group of neurons, right? So and pointing from pons. Okay, so it's a nucleus in the brain. So again, the pons is kind of regulating more breathing rate. Okay. So regulates breathing, swallowing, balance, chewing, and salivation. Okay. So the critical parts that we have seen that are controlled by the brainstem so far is the blood vessels, the vasomotor center in the medulla, and also the breathing. Okay. Kind of like the depth of breathing and how shallow it is, depending on the activity. So that's why it's critical. So you can, if you hit small parts of the brainstem, it could be a fatal thin, you know, because of the functions of the brainstem. All right. So there's the point, there's the bridge, and there's the bulge. You can see it in an actual MRI. All right. So we're kind of starting low and we're going up. All right. So here goes. So the brainstem again. The midbrain now connects to the upper parts of the brain, and it's got 4 sort of round nuclei or groups of neurons, if you will. Okay, where you've got the superior colliculus, okay, which is 2 little mounds like that, sort of like that, that deal with vision, and then you got the inferior colliculus that deal with hearing. Okay, literally the superior colliculus. Collicular means heel. This means heel. Okay, that's a Latin word meaning heel, and it's 2 of them. Okay, so all these parts are called the corpora. Remember, we're gonna do it when we do brain structure in AB2. Corpora quadrigemina. Okay, which is this here. Corpora means bodies, and quadrigemina 4 of them. That refers to the 2 superior colliculi and 2 inferior colliculi. All right. The inferior colliculi deals with hearing. Okay, so that's in the midbrain, and the 2 superior colliculi deal with vision reflexes. All right. So there are other parts, other nuclei, okay, or groups of neurons in the midbrain that are named after the color, okay, because of what happens in the metabolism there. So the substantia nigra literally means black substance, okay? And it's another nucleus that's involved in controlling motor activity, okay? It's substantia nigra because it has a lot of melanin in it. Melanin, you know, it's what gives the color. The more melanin you have, the darker you are. So there's a lot of melanin in here. Melanin's main function, apart from giving the color, is to protect from, mutations and, reactive oxygen species like oxidants that will attack body tissue and destroy it. So melanin is there because the substantia nigra metabolizes dopamine, which is involved in motor activity, and therefore in the metabolism of dopamine you create all these very reactive oxygen species that can attack the brain tissue. So you have a bunch of melanin in it, and therefore it's dark. Okay? Because dopamine is what is also involved in Parkinson's disease. You know, Parkinson's disease you don't need because it controls motor activity. So that's what these nuclei do. Okay? So the other one is the red nucleus, and because it's red, it's got a lot of blood vessels in it, so it's got a pinkish color to it. Okay? And they're all to regulate body movements. Usually they cancel unnecessary motor activity. Have you seen in people with Parkinson's, they shake? Because unnecessary motor activity is no longer being cancelled by these nuclei, these parts of the brain. Okay? So that's the midbrain. It's split into all these different parts. See what I'm saying? Yeah, we're splitting it into smaller and smaller chunks and then saying what it does. Okay? If I ask about the corpora quadrigemina and I say what are the 2 functions of it, or if you then say the superior colliculus deals with vision, and then the inferior colliculus deals with, hearing. Okay? Then the substantia nigra and the red nucleus, the ones with the color, they deal with body movements. Okay? They cancel unnecessary body activity, body movements. And the cerebral pedicles, connect, they are tracts that connect to, the cerebellum and also the cerebrum. Okay? And, they carry motor information from the upper parts of the brain going down to the body parts, to the muscles. Okay? So you can see the midbrain is doing quite a bit. Okay, but the medulla and the pons, are dealing mostly with the breathing and the cardiovascular center. You see what I'm saying? Which are very critical parts. And also these are critical because the hearing and the balance is also good, but it's not, it doesn't kill you if you don't lose your vision. So it's the other two that are really serious. Okay, so there you got the midbrain, and it connects to the giant cephalon and the medulla over there, having the cerebrum, right? Okay. So if you were to take a cross section through the midbrain, like that, okay, right there, this is what you see. So this will be the red nucleus. Those two nuclei that will control the motor activity, all right? And then, of course, you see these black spots because of the melanin. That's the substantia nigra, all right? Because it metabolizes dopamine and it creates all these species that can attack, the brain tissue. So you have a bunch of melanin, which makes it black. Substantia nigra, black substance. And then, of course, the cerebral aqueduct is that mid piece where you have this cerebrospinal fluid, and it connects to the fourth ventricle. And we'll talk about it in NB2. The first lab will cut through the brain, and we'll see all the structures. All right, and then of course the superior colliculus that deals with vision. Okay, you can see those two little hills there, and then the inferior colliculus, you can't see it because it's kind of under, so the cross section doesn't go through it. You see what I'm saying? The cross section, so the inferior colliculus that deals with the hearing is not on the cross section. And then, of course, these are the cerebral peduncle, those tracts that connect motor activity to the lower parts of the brain. Right? So there you go. So in the brain stem, scattered throughout from the midbrain, the pons, the medulla, are certain nuclei. It's like a system of neurons that are called the reticular formation. All right, and it kind of controls sort of cyclic movements like walking, things like that, chewing, anything that is kind of cyclical in chewing. When you're chewing, have you noticed how you conveniently miss your tongue from biting it? Sometimes when you're eating fast and you're talking, you chew it up, and that's painful, right? But most of the time, you never chew up your tongue. And how is that controlled? By that. Okay? So it's controlled by this reticular formation, which is scattered throughout the brainstem. All right? Because chewing, you have to be careful. Because you could easily chew up your tongue. That would really suck. Okay? Within that reticular formation, there's a part that deals with waking up the cerebrum. Like in the morning when you wake up, you wake up groggy, right? That's because you're not fully awake, and it's because this reticular activating system is activating your cerebrum into a state of wakefulness. Okay, and that's located in the brainstem. Okay, so part of the reticular formation is the reticular activating system, which arouses the cerebrum to a state of wakefulness. After a while, after you've woken up for a few minutes, then you're up. You're really up. You wake up and you're a little groggy. That's because this is working. Okay, so and therefore it kind of regulates the sleep-wake cycles because of that. All right. So it's still the brainstem. You see what I'm saying? We've been talking only about the brainstem so far and the different parts of it, and there are many functions. So that's why it is this critical function. Right. All right, so and now we go to the cerebellum. Cerebellum literally means small little brain, because it's the same structure as the cerebrum, but smaller. All right. So again, it is the gray matter, which is the cell bodies of the neurons in the brain on the top, and that forms the cortex. And the white matter in the middle, which is mostly those myelinated axons of those neurons up there in the cortex, right, forms the medulla. Okay, or the second layer of it. Okay. And then it's got the nuclei, the different parts again that deal with different stuff. So we'll split it into three major parts. The cerebellum, and talk about the function of those three major parts, right? So, like I was saying earlier on, arbor-vitae means arboretum is tree. The structure of the cerebellum is like a tree, with a trunk and leaves and whatnot. So it's called the arbor-vitae structure of the white matter inside. And of course, it connects, the cerebellum to the rest of the system, the cerebrum, and so forth. All right. So there are certain nuclei that deal with certain things right there in the cerebellum, and we'll talk about each one. So three major parts. The flocculonodular part, ocular, you can start to imagine it deals with the eyes. You know what I'm saying? And then balance, because you need your eyes to balance. Have you noticed how it's difficult to balance when your eyes are closed? See what I'm saying? Because you need vision for that. So the flocculonodular, some of these parts, for the most part, they kind of tell you what the part does, because that's how they are named. Okay? So this should remind you of eyes, something to do with eyes. So balance and eye movements, flocculonodular. Okay? So cerebellum pretty much is the part where you learn to do complex activities, complex movements. Like when you learn to ride a bike when you're young, it's the cerebellum that does that, because it controls fine motor activity. When you learn how to dance, so if you're a talented dancer, like if you've been watching, so you think you can dance, it's because their cerebellum is really well developed, if you will. Because that's where they learn the dance from. Because some people can't dance, they don't have the groove. Because this is the part that controls it. Okay, so like I was saying, the cerebellum has got two parts, the hemispheres, which are called cerebellar hemispheres. And in the middle, there is this connector, which looks like a worm. It's called vermis. Like vermin is worm, vermin. So the vermis from vermin is like a worm-like structure that connects the cerebellar hemispheres. Okay? So it deals with fine motor activity coordination, okay, control of posture, locomotion, all right, fine motor coordination, all right. And then of course the lateral hemisphere is kind of like the brains, the major part of the hemispheres. So it's like planning, complex practice, movements and so forth. All that is done here. Learning complex movements, like dancing, riding a bike, things like that, and so forth. All that is controlled by the cerebellum. So you gotta know the three parts and what each part does. Okay? Because each part is kind of divided into smaller sub-parts. Alright? Because in the exam I made this specific about the different parts, tell me about the parts of the cerebellum and their functions. Two parts, and then you talk about the flocculonodular and so what the hemispheres. And there's the cerebellum here with the MRI, so you can actually see where it is. You can examine this later. You see, this is the vermis right in the middle. These are the hemispheres, the cerebral hemispheres. All right, and you can see the arbor-vitae kind of structure here, tree-like structure and shape. All right. Okay. So now the giant cephalon. The giant cephalon is a smaller part again, and it's got a lot of functions. The hypothalamus has got a bunch of functions too. In the thalamus, like I said, that's where all sensory information goes through the thalamus. It's like a triaging of the brain. You know what I'm saying? Like when you go to the hospital, you have what they call triagenase. We kind of sort the patients into the most sick, so they get seen first, okay, and then the guys who are maybe coughing or complaining of something, they put then they deal with them later, because you don't want to attack, deal with somebody who's got a cough while somebody's dying with a heart attack over here. You know what I'm saying? That would really suck. So that's what the thalamus does. It helps the brain to decide which is important sensory information so that it deals with it. If it's kind of like a nuisance, it kind of gets ignored, until it has to be dealt with. that kind of thing. So the thalamus is like the triage part, and everything goes through there except smell. Okay, only sense that doesn't go through there is smell. Okay, so under the thalamus is another nucleus called the subthalamus. Immediately under the thalamus. Okay, the thalamus is a circular structure, and you will see it when we dissect the brain. So the subthalamus will be here. Okay, and then the epithalamus, which is kind of made up of two nuclei. The pineal body is kind of on the top and kind of to the back of it. All right, and then there's another one called the habenular nuclei, which is kind of like there too. Okay, which deals with different stuff. Okay, so it's got to do with the thalamus. Everything is kind of in relation to the thalamus, which is really the central nuclei of the brain, where all the information is sent except smell. And then the hypothalamus is underneath it, and then hypothalamus follows. Okay, and then under the hypothalamus will be the pituitary, and the hypothalamus controls this pituitary here. All right, and the pituitary lies. I'll show you another picture in the sella tessica, which is that little C-shaped cup in the scalp, in the base of the scalp, floor of the scalp. All right, so we'll talk about each of these and their functions. Okay. So the diencephalon. So the thalamus really. It's like a yo-yo. The thalamus is like a, yo-yos? These days you guys don't play with yo-yos because you got all these games. It's literally like that, and then it's got another one. Then it's got a connector in the middle. Okay? The interthalamic adhesion. Alright? And then, the string will be here like a yo-yo. That's exactly what it's like. It's one lobe in the left and the right cerebral hemispheres. Okay? So that's what that is. Okay, so it's like the integration center. It's like a center that kind of decides which part of the brain best takes care of a certain sensory stimuli and which sensory stimuli to address first, okay, before others. So like I was saying, everything, all the sensory information that goes to the central nervous system, that goes to the brain, goes through the thalamus except the sense of smell, okay? That's the only one that doesn't go there. All right, it has to go through the thalamus first. So, it interacts with definite other parts of the brain and sends the certain sensory information to a certain part of the brain that will best address that particular sensory information. All right, and it's also involved in emotion and pain. Okay, emotions, perception of those things, because pretty much all the senses are going through there, and they need to determine whether it's a pleasant sensation or it's a not so pleasant. Right? Okay, so the thalamus does all that. Pretty much it kind of decides which impulses to take care of and which ones are important enough to be addressed first, and then it sends it to the correct part of the brain. Remember, the brain is split into all these parts that specialize in certain functions. So the thalamus will send it to the part of the brain that best deals with that.
So it's kind of like
It directs the whole activities. Directs. This goes here. Okay, we don't deal with this now, but this goes there. You know what I'm saying? It's a very important
part.
It's an important part. Yeah. The small parts are the important. They come paired. The cerebrum, you think, oh my God. But it does important
things. If your thalamus isn't telling things what to do, then you're kind of screwed.
The cerebrum is kind of like the army. The big part of the brain, the cerebrum, it has all the soldiers. But these guys are the generals. They're deciding who does what. See what I'm saying? Like the thalamus and the, all those parts. The brainstem is controlling all those things. All right, so the subthalamus, of course, is inferior to the thalamus. It's the first part that is just immediately inferior to the thalamus. And it's involved in motor function, motor function. It controls motor activity. Okay, so that means it controls anything that says motor controls what part of the body? Skeletal muscles. Because those are the guys that motor is to do something, is to drive, to do something. So it controls skeletal. Whenever it says anything says motor, skeletal muscle. Okay? Because those are what do things, you know. And some glands and things like that, but for the most part, it's referring to that. Okay, epithalamus is the one that I said is slightly above and behind. So that's superior above and posterior kind of behind. You know, posterior is the the more correct terminology. But it means kind of slightly behind it. So the habenula nuclei, kind of deals with the emotions that are related to smell. For instance, if you're in the bathroom and you're doing number 2, the emotions that come out of that are not so pleasant, right? Depending, some of you, it's really bad. But if you take a bouquet of roses, then the emotional experience from that is going to be pleasant. So the habenula nuclei, decides about that. How to respond to stimuli to do with smell. Okay? So this one you should remember. If I ask about the habenula, you just think of number 2, and you know what it means. All right? The pineal body kind of produces a substance called melatonin. And that was something. So melatonin is involved in kind of sleep-wake cycles. If you have taken sleep medication, you notice that there's melatonin in it. Okay, and melatonin kind of sort of controls the sleep-wake cycle. So the pineal body kind of does that, and it sort of deals with the onset of puberty. But really, what it produces is melatonin, which is involved in sleep-wake cycles. Okay, so sense of smell and emotions due to that, and then here sleep-wake cycles and kind of sort of the events that happen in puberty when you start to secrete more hormones and things like that. Okay, so that's the epithalamus. Okay. Now the hypothalamus deals with all the visceral activities. It deals with pleasure, it deals with hunger, thirst, all those things controlled by the hypothalamus. All right? And it's also the autonomic control center because it releases hormones that cause the release of other hormones in the pituitary. Okay, the anterior and posterior pituitary are controlled by the hypothalamus. All right. So any sort of soft internal organ functions, blood vessels, the digestive system, all those things. Viscera means soft internal organs. All right. And therefore, it's really the center of all the homeostatic mechanisms, right? Because it will have a bearing on everything. Things like thirst can control blood pressure because, the amount of hydration equals the amount of blood you have. The amount of blood you have equals the pressure. If you have low blood volume, low blood pressure, no good. Like if you start losing blood, if you've been short or whatever, God forbid, and you lose blood, your blood pressure starts to go down, 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 until they might have to give you a transfusion when you get there to pump it back up quickly, because it will take a long time to replace that blood. Okay, so this autonomic control center controls all those things: heart rate, blood pressure, and so forth. Therefore, it will control things like thirst, drinking water, hunger, and things like that, getting energy. So, kind of like a center for emotional and response and behavior. Okay, because it controls all these things like eating behavior, you get hungry or whatever. Okay, it's controlled by the hypothalamus. So it regulates food intake, water balance, thirst, control of the endocrine system. Like I said, it releases things like growth hormone releasing hormone, which causes the anterior pituitary to release growth hormone, or corticotropin releasing hormone, which causes the adrenal gland and all these other glands to produce other hormones. So it controls the endocrine system because it produces hormones that, I think, remember we did the endocrine system, we know about the endocrine system and all the hormones. So because the hypothalamus releases all these hormones, remember we talked about how the hypothalamus controls the anterior and the posterior pituitary, and I think it was in the exam too. You see what I'm saying? There you go. Yeah. When we were talking about hypothalamo hypophyseal tract, hypothalamo hypophyseal portal system and so forth, this is it. Okay, so the information is kind of building up. Some of these things we kind of already know about it. We know about the involvement of the hypothalamus in the endocrine system already. If I was to ask you about the functions of the hypothalamus, you should have no problems, right? Because it controls a whole bunch of things, thirst, all these things, water balance, hormones, the endocrine system, body temperature, all those things, food intake, pleasure, things like that. And then there are little, you see, all this is the hypothalamus, and it's split into all these small little parts that deal with all those functions. And you can look at this later. But really, I don't really care if you know where the location of that little part is, but I just want you to know the functions, all these functions, which kind of makes sense, and they kind of bunch together too. All right. So the mammillary body controls reflexes for the olfaction. Olfaction, of course, is smell. Okay. So that's part of the hypothalamus that deals with, you notice how smell features through all these other, everything but the thalamus. You see what I'm saying? Because those are all the other parts that smell is not like a critical, like function. In fact, it very much adapts. Like in the morning when you spray your perfume, what happens, or your cologne or whatever it is? What happens in the morning? You smell it for like 2 seconds and then that's it. Does it mean it's no longer there? No, it's still there. Because smell is, you don't need to be smelling yourself the whole day. It becomes annoying. You see what I'm saying? So it gets cancelled quickly. But if you come in the morning, I'll smell you for the first time. And then after that, I may not continue to smell you. Because, you see what I'm saying? That's why you don't smell yourself the whole day. That would be kind of an annoying thing because you've got other things to focus on and you're busy smelling yourself.
But maybe if you could smell yourself all day, you would realize that you don't smell good.
Depending on which cologne you wear, right? So there's the pineal body, which is kind of sort of above and behind the thalamus, and then you got your diencephalon marking the whole thing. Okay. So these are parts of the diencephalon. All right. There is the hypothalamus, the thalamus, and the subthalamus, and so forth and so forth. All right? Pictures. Cerebrum, okay, this is like the major part of the brain. Most of the mass of the brain is the cerebrum. And it's got the same thing. It's got cortex, which is a bunch of cell bodies. And this cortex, it's about 5 millimeters thick, the cortex, and it's gray matter. Because gray matter includes what? We know about gray matter, right? Includes unmyelinated structures. And most of the unmyelinated structures are the dendrites in the cell bodies, because the cell bodies never get myelinated. Okay, it's only the axons that get myelinated. Okay, so the cell bodies of probably 75% of all the neurons in the nervous system, they're located in that cortex of the cerebrum, and then the tracts just come down with the white matter. Okay, the gross structure of the brain, it's got these bumps and squiggly bumps. Okay, called gyri, plural. Gyrus is singular, right? And then the grooves, those little grooves, squiggly grooves, called sulci, plural. Sulcus is singular, okay, or fissures, all right? Resist the tendency to think grooves are called gyri, GG, no. Grooves are, at the sulcus, or sulci, plural. Okay? So, right in the middle of the brain, there's a crack, almost like the butt crack, actually, that separates the two cerebral hemispheres. And that's called the longitudinal fissure. And it separates the two. So, these are the parts of the cerebrum, all right? The frontal lobes, which is under the frontal bone, they kind of deal with judgment, okay, and character, and complex planning, like in working memory kind of thing. Working memory is the memory that you have when you're doing stuff, okay? And I'll show you again these lobes and what they do, sort of complex planning as well, and working memory. Working memory is kind of short-term memory when you're doing something, okay? And the parietal, P, usually are associated with pressure, so it senses pressure. Therefore, things like touch, okay? Things like temperature, dealt with, T with the thing is temperature is all to do with the parietal lobe. Occipital is at the back under the occipital bone. That deals with vision, okay? Eyesight. The temporal, right by the ears, you can't miss that. It deals with hearing, and sometimes a bit of smell and other things like that, okay? The insula is the last. It's also considered a lobe of the brain. It's the fifth one, but it's very small. There's the central fissure that, lateral fissure that kind of goes across like this. You know, the central one here, and then there's kind of a lateral sulcus. And that, in that crack there will be, so it kind of goes like this, and in the crack will be the, and this is the part of the brain. That will be the insula. Insula means island. It's hidden. It's kind of like an island in there. And it kind of also deals with smell, taste, okay? Sensory impulses go there, okay? I'll talk about each of these and their functions. But that's basic functions of these major parts of the cerebrum, the lobes, pretty much under. So the crack I was talking about is there, and I'll show you, and the insula is kind of in there. So there's the cerebrum, then the frontal cortex. This part here kind of goes down like this. It's the prefrontal cortex, and frontal cortex, the parietal, and the occipital is back here, right, and the temporal right on the sides, right? So there's the longitudinal fissure, okay? And you see the grooves are called sulci or sulcus, and the bumps are gyri, or gyrus is singular, okay? So that's the gross structure of the brain, all right? Again, the longitudinal fissure there, okay? And then you see the gyri, and then the sulcus is highlighted, all right? So this is what I was talking about. The central sulcus is this sort of crack in the middle here, this groove that separates the frontal lobe from the parietal lobe, okay? And then this one is the lateral fissure, where the insula is located kind of inside of it, and this is the temporal lobe right by the ears, and the thing hearing and stuff like that, okay? And then the occipital at the back for vision is right under the occipital bone, all right? And it kind of runs along the lambdoid suture as well, okay, which we did when we did the skeletal system, all right? All right, so there you go, the different parts. And then this is just going to show you each lobe, you know, the frontal lobe, and then it's going to show you the parietal. Okay, the parietal is right here under the parietal bone on the side, and then of course occipital at the back for vision, right? There you go. And then of course the temporal for hearing, all right? And then there's the insula kind of hidden right here, all right? And there's this lateral sulcus right here, along there, and then that's kind of like the location. So insula means island, it's kind of hidden in there. And this is just an MRI, you can look at it later, of an actual human, right, showing the different parts. Okay. So, the frontal lobe, then that's one that's involved in voluntary motor activity, function, motivation, aggression, judgment, you know, things like that. There was a railway worker who was quite a long time ago, who they were blasting out stones, and you know, he was inserting the dynamite with a metal rod, and the thing blew up before he could get out of the way, so it went through the frontal lobe. Okay, he was again conscious. He didn't, you know, he was impaled, but he was conscious. Thank God the brain doesn't have pain receptors, don't you think? Because if it had, it would be really sucky. Because that's where all the neurons are. You know what I'm saying? All the intensity of the pain would be unimaginable. It would totally switch you off.
So then your body doesn't go into shock then because it's not feeling pain.
Yeah. Yeah. So you remain conscious even though you are impaled in the brain. It will be freaky to you. You might pass out just from the fact that, you know, but you'll be conscious. You'll be right there. And you know what happened? You know, he survived and so forth. You know, no outward damage or anything. They removed it and whatnot. He was a very trustworthy guy, always early to work and so forth. Well, after he healed, he was no longer trustworthy. He was a robber because all the judgment and all the consequences, judging actions is done by the frontal lobe, so that was damaged. So he became the opposite. He was more criminal behavior now because of damage to that. Okay? So, and it does mood, all these things. That's the frontal lobe. The parietal lobe, because P I usually associate P with pressure, so therefore things like touching, temperature, pain, okay, P for pain as well, okay, temperature, balance, taste, okay, parietal lobe, all right. So occipital lobes, visual centers, it's right at the back there, free vision, all right. The temporal lobes, they kind of evaluate smell, hearing input, right by the ear, okay. Usually you remember things you hear because it deals with hearing, memory, okay, and then abstract thought and judgment, kind of things that are abstract, things like that, that are kind of not, neither here nor there, but mostly
sense.
hearing, yeah, kind of, abstract. Well, it's not really abstract things. It's kind of things that are fuzzy. It's like, it's not like very clear-cut things. It's kind of like, it's not the common sense kind of things. This would be kind of somewhere up here, motivation, mood functioning, and things like that. But here, it's kind of like some of those fuzzy things, fuzzy areas, abstract, something that's not quite, well, constructed and so forth. It's abstract. Okay, so, and then judgment a little bit, okay? And then insula, is located deep within the lateral fission as well. And it has some function in taste as well, but it's one of the smaller ones. It's still considered a lobe of the brain, right? So there is that. All right, so of course, kind of sort of know a few functions for each of these lobes, all right? Because sometimes I ask, can you list the different functions? I mean, the different lobes of the brain and their function for two. So now they are, because the cerebrum is humongous, right? It's huge. It's the biggest part of the brain. It's going to need to be connected by these axons. That will be myelinated, so it's white matter, right? And so and these axons that connect the different parts of the cerebrum, those are the fibers that we're going to be talking about now, okay? Because the gray matter will be having all those cell bodies, and then they are, you see, it's almost like this. So you have cell body, cell body, cell body, and then these axons of those, so this will be the cortex. And then the medulla in there will have all these tracts, which are the axons. All right, that consists of the white matter because all those axons are myelinated. Okay, so association fibers will deal with connecting parts in the same hemisphere, like in the right side or the left side. So the association, in the same side of the brain, they connect different parts on the same side. Commissural usually connect, not usually, all the time, connect the left and right hemispheres. Okay, there's a minor part actually called the anterior commissure that connects the left and right hemispheres. So it's from one hemisphere to the other. Anterior commissure from commissural, right, is the minor part that connects the left and right hemispheres, but the major part is the corpus callosum. In fact, it has got almost 300 million tracts or nerve, between the left and right. It connects the left and right. Okay? So it's like the whole population of the US crisscrossing from this side of the brain to that side of the brain. That's all in the corpus callosum, which is very white because it's got these myelinated axons connecting the two sides. Okay? So that's commissural. Projection, they kind of connect the brain to the lower parts. Like those ones that desiccate in the cerebellum, those will be the projection fibers. They connect the cerebrum to other parts of the brain and the spinal cord. They are projecting out. Association in the same hemisphere, commissural between the two hemispheres, projection away from the brain, from the brain to the other lower parts Okay, so sometimes I say, okay, these fibers in the brain that connect, the different parts of the brain, can you name them and talk about what they connect? So this will be commissional, right? From left to right. This will be the projection, right? And then these association ones, some of them are tiny in the same hemisphere. Okay? So there is that. You can see them. You can see the top part, and then see all these fibers when you dissect through the brain. It's like all the neuron cell bodies are up in the cortex, and then the fibers go down. Okay? Cerebrum. So in the cerebrum, there are certain nuclei. Remember, nuclei simply means a group of neurons in the central nervous system. That's all it is. And these groups of neurons specialize in a certain function. Okay. So these basal nuclei are kind of involved in motor activity. Okay. And in fact, these are the ones that are involved in Parkinson's disease, including some of the other ones we mentioned, like the Function-Tue. But there's 3 of them that are really involved in the Parkinson's disease, and I'll cover them at the end in a little bit. So those basal nuclei that are located in the cerebrum are called corpus striatum, because the corpus means body. So this is a striated body. It's got striations on it, like streaks. Okay, so the corpus striatum would be the caudate nucleus. Caudate, which means caudal tail. It kind of has like a tail, like look to it. Okay, and the lentiform. All those are corpus striatum. They're collectively known as corpus striatum because they've got little streaks on them. Okay, and the lentiform looks like a lens. Lentiform, lens. It looks like a lens. So the shape of it is kind of like this. And the caudate one kind of has a tail, kind of like tail appearance, something like that, something long and caudate. Those are the basal nuclei in the cerebrum. Okay, there are other nuclei located elsewhere, like in the subthalamic nuclei, which is the diencephalon. That would be the diencephalon. Remember, we said the thalamus and the hypothalamus are the diencephalon, and then there's other parts like epithalamus, subthalamus. Right? So this will be the diencephalon. But the basal nuclei in the cerebrum, those are the ones that are called corpus striatum because they've got striations on them. And that's the caudate of the lentiform. And then the subthalamic nuclei and also the substantia nigra, which is in the midbrain. Right? Substantia nigra, remember the black substance, okay, control motor function. Right? So basal nuclei control motor function. So the basal nuclei that are involved in Parkinson's disease would be these guys. The one that Mohammed Ali has, the caudate nucleus, which we just mentioned, which is one of the corpus striata, the putamen nucleus, and the globus pallidus. All those control unnecessary motor activity, okay? And they are involved in Parkinson's disease. And they're all related to the cancer of unnecessary motor activity. All right? Okay, so the cerebrum again is big. It's got all these other functions on it, but it's mostly directed by the first parts we talked about. Okay? So, a system is a group of organs, right? So, groups of organs and so forth will be these parts of the brain, that deal with certain structures. So, the limbic system is kind of spread throughout the diencephalon, spread throughout the cerebrum, goes all over the place, connecting all these different nuclei that does all these different functions. And it mostly deals with emotions. When you think limbic system, think emotions. It really controls the emotions. It's the emotional output out of all the sensory information that is gathered by all those different parts. Okay? So it deals with that emotional output. So the limbic system really is big part is emotions. But it does other things as well. Because you see, it connects all these motor nuclei, like the basal nuclei, all right? You see, the thalamus, and the thalamus, pretty much everything goes through the thalamus, right, besides smell. Okay, and the hypothalamus, you see all those functions that it does, the hunger, thirst, everything, all those things, okay, they're all connected by the limbic system, which kind of sort of organizes all these into an emotional output based on that sensory information, right? So, because it has all these things, it deals with memory too, because it connects all these different parts, and that's how you generate your memory, based on your experience and your sensory stimulation. Okay, so when you're reading, you're studying, you are reading and you're sensing your sight, and you could see. Sometimes if you're allowed hearing too, all that goes into the memory. That's how you generate memory, by actually changing the shape of your neurons, and that deals with that. So it involves the emotional interpretation of all the sensory information. So and then it generates emotions based on that. That's the basic function of the limbic system. But it connects all those structures and what they do. Okay, you see all that. All that is the limbic system. All right, and that's it. So thank you, ladies and gentlemen. We shall see you in a little bit. All right.